Yeah.
Absolutely. Yes. And not only did you make the thinking visible, you gave students the opportunity to talk about the work that they're noticing. Hold on to that thought. We're going to watch this video together of a teacher who used guided discourse. I'm going to share my screen so that you can see it. Here it is. All right, can you see that? All right, okay, I'm gonna press play.
So let's take a look at A and B. What do you guys think about the work you see in A and B? Loving the strong focus I'm seeing. What do you guys think? Turn and talk with your partners. Go.
They multiply.
I love the hands that I'm seeing. I just want to do a quick poll first. Put a 1 up if you think that A is the correct one, a 2 if you think B is the correct one. 3, 2, and 1. Great. Love that I'm seeing all 2s here. It's a fist if you're not sure still at this point. Okay, great. Why is 2 the correct one? Track. Tyler, be ready to build.
B is the correct one because it multiplies all the terms by 6, not just one term.
So what's the error, Tyler?
The error in number in A is that it doesn't multiply 6 by 5.
Great, build. Agree, disagree, use apps of discussion. Track. Sadi.
I agree with Tyler, and I say B is correct because when that person whoever did it multiply to make both equations equal, he multiplied 5 by 6. He multiplied 5 by 6 also, which got him to 30. And then the first person that did the first one didn't do that, which made the equation wrong.
Great, so one more time in your own words, what's the error and why? I should see a ton of hands. What's the error and why? Track. Danny. This one we know is incorrect. They did not multiply the 6 by every single term. So now I want you guys thinking about why B is correct and give me some great explanations. What's the math behind it? What do we need to do as strong mathematicians to get these kind of questions with elimination right all the time? What do you want to keep in mind? Turn up with your partners. Give me some great conjectures. Go.
Multiply terms by the same number, because if you don't multiply it, you're not going to get the same thing.
Let's see some good conjectures. What do you guys think? Track. Nigel.
I said we must consider the golden rule of algebra, because what you do to one part of the equation, you must do to all parts of the equation. So, like in student A, when they multiplied 6 by only the x and the y, they should have multiplied it by the 5 because you must multiply by all terms to keep your equation accurate.
Awesome. Because I just love. I loved your explanation. So can you give me the conjecture one more time, in which I should write? When
using elimination, multiply all terms by
the same or different value.
Yeah, by the same number to keep your equation accurate.
Can someone give Nigel? Actually, Nigel, can you put yourself for a better word than accurate?
To keep your equation balanced.
Okay, awesome. I love that. Nigel's giving us a step, what we should be doing and considering. Can someone give me the larger idea? What property does that apply to? Ooh, loving the hands that I'm seeing. Track. Christian.
You have to
Pause really quickly. This is a really important point. Make sure you're tracking, Christian. We'll have a moment to copy this down. Track, Christian.
It's called the multiplication property of equality.
What does it say?
In order to keep the equation balanced, you have to multiply all parts of the equation by the same number.
Great, and that maintains what about the equation? Maintains its what?
It makes sure the equation is equal.
Good, make sure it's equal. Great. So the multiplication property of equality states to preserve equality, multiply all parts, all sides, by the same value. So as you guys do the rest of your work in your independent practice, please make sure you're keeping that in mind. Go.
All right. So what did you notice about her leading critical discourse or guided discourse?
Actually, I noticed the teachers not only put the students so visible, and she have a lot of chance to make students turn and talk, and students will much more engaged. Sorry, because
Absolutely. Yes, you're right. It's much more engaging. She used the student work that's in the room.
one second, okay. And I also noticed about the teachers. He didn't after the students talk about which one is right, and maybe we should correct it. What is wrong? What is the wrong part? Then teachers will help students to talk more about how to conclusion their findings. Then they will write, and then write down the students' finding and do a big idea. So the finding is come from students, not just the teachers talk to students. Students will have much more agency and engagement. Yeah.